Hi everyone, good evening. Welcome you all to another session of AI ML. Today we are going ahead to see all of the things that we have discussed in the previous session. We will go down and see how we can perform those work specifically in Python, using Python basically. In Google Colab, you can use any other Python editor like IDE that you are having with you. You can use the Spider, that IDE is also works good. Also, you can use the Jupyter Notebook. But for better understanding, we will be using Google Colab, that is very much efficient, and any one of you can use that and work with that. Okay. So for this, let me share my screen so that you can so that I can just show you the data set that we have taken in, and based on that can go ahead. Okay. So let's just go ahead with it. Okay. I am unable to share my screen. Just a moment, please. Uh, Getting some issues. Yes. Okay. So I hope my screen is visible and my voice is also audible to you. So you can see this is the UCI heart disease data, and this is from Kaggle that we have taken it. Basically, we'll be using this to take it and make it going basically, and we will be taking this data for further analysis. We'll do all of the analysis over this data, and based on that we'll go ahead. So you can see this data accordingly. It contains 16 columns accordingly, and we have taken all of the columns accordingly. And if I just go ahead, go for select all and apply. So here you actually get what each of the column description you will be getting. So you'll be getting the ID, that is the unique ID for each of the patient. Coming down the age of the patient in years, you'll be getting. Next, you have origin, that is the place of study. Next, you got the gender of the patients, basically, that is male or female. Next, you have got CP. CP is the chest pain type. So there are different chest pain type that we are getting. That is typical angina, atypical angina, non-anginal, asymptomatic. Next, we are getting T-rest BPs, that is resting blood pressure, that is resting blood pressure in mmHg on admission to the hospital that we are getting. Next, we are getting this cholesterol, that is the serum cholesterol in mg by dl that we are getting. Then we are getting FBS, that is fasting blood sugar that we are getting up here. Next, we are getting rest ECG, that is resting electrocardiographic result that we will be getting. The values are normal, STT abnormalities, IV hypertrophy, all of this. Next, THALACH, that is maximum heart rate achieved that we will be seeing. Next, this we have XANG, that is exercise induced angina. The result we are like values we are getting as true or false, like that. Next, we will be getting this old pig, that is ST depression, that is induced by exercise relative to rest that we have got. Next, we have got the slope that signifies the slope of the peak exercise, ST segment that we have got. We have got CA, that is the number of major major vessels, that is 0 to 3, colored by fluoroscopy, that we have got. Next, we have got THAL, that is normal, fixed defect, and reversible defect, that we have got. Next, we have got num, the predicted attribute that we have actually got. Like this, our data set is going. And if you want to see it, this is how my data set, like the data set that I am choosing, that is going. Like if I move it up here, so resting blood pressure is going with this numerical values. Next, fasting glucose, blood sugar basically, that is coming with the Boolean form. This is how it is going, right? So we will be taking this data for further understanding about how to go ahead with doing all of the steps, and also about the visualizations. Okay. Basically, we will be doing the whole EDA here. Okay. So this is my data. So first, we will be like, it's recommended to work with Google Colab, because here you get the option of text basically. You get a text field along with the code. So because for starting with the project, you need some of the code part that needs to be there. So we have to add the project name, project type, like who have prepared the project, of course, the person who would be preparing it. Coming down, we have the project summary, the problem statement. Now coming down to the coding section. Okay, so here one by one, like by each of the line of the code, we will be understanding what it actually meant and what exactly we want to do up here. Okay, so that you can understand it and try to implement it in your code and try to get a better access of it. And eventually, when you will be working with any of the project, you can follow these steps, because these are the standard steps that needs to be followed accordingly. Okay. Coming down, we have to first import the libraries. Basically, here we are have got majority of the libraries, because without the libraries, we won't be able to perform majority of work. So we have imported the library. So first, we need to work with the data tables. That is the reason we have used pandas. So we have imported pandas as PD. So pandas is like the, as you know, it is a Python library. So it can hold the data in rows and column format, just exactly like that we have our data in Excel. So my data is in CSV format. So when you'll be downloading it, so here you have got the data. Now when you'll be just clicking up here, so you'll be getting the data in CSV format. You can see the name as well, heart disease UCI.CSV. So my data is in CSV format, and I want this data to be incorporated here. Okay, sorry, just a moment. Yes, here. Here to just visualize and analyze about the data, right? So for that, I have the data in CSV format. So Python can read CSV with the help of pandas library, right? So that's why I am using import pandas as PD. So it will be taking my entire data into rows and columns like a table format. So we have used pandas as PD. So PD is just the short nickname for pandas. So we don't have to type the full pandas every time we are going ahead. Okay. So we need pandas to read the data, to clean the data, to analyze the data. Okay. Coming down, we have import NumPy as NP. So NumPy is basically doing all of the mathematical calculation faster. So NP is again the short name of NumPy. So we need it to do faster mathematics. We need to work it with a lot of the numbers basically. So also we need to calculate some of the very bare minimum, going down to the advanced formulas like average, sum, mean, max, and many others. So for that, we will be using NP, that is NumPy. Okay. Coming down, we have mat import Seaborn as SNS. So Seaborn actually helps us to make beautiful and colorful graphs. So SNS is like the short name. Okay. So to make the bar chart, to make the line chart, the heat map, we are using Seaborn. Okay, so a chart actually it will be showing which product hold or like suppose which product is holding more like that if we are having this kind of example. So we will be taking the visualization from that and we will be going accordingly. Next we have matplotlib dot pyplot as PLT. So matplotlib is again a Python library that we are using for visualizing the plots just like we are doing for Seaborn. So it's like a drawing book for data. You can say in a like real life if you want to connect it. So plot PLT is basically the short name. Okay. So if you need to draw the graphs, we need to show down the charts in the screen. For that, we need Matplotlib. Okay, coming down seaborn is actually actually uses this matplotlib behind the scenes so that they can work together, right? For that we need both seaborn and matplotlib together. Going down, we have imported Missingo and as MSNO. So Missingo actually helps us to find the missing data, right? So missing data, if my data set having missing data or not, that I need to find out. Like basically, I need to visualize. In that case, I use Missingo. So I need to see which data is missing to understand where values are empty. So we need this Missingo. Coming down to the warning, you can see that is import warnings we have used. So import warning, it simply means like suppose something is wrong, right? In that case, we need it. Sometimes this warning are not that important to us to get this like I don't want that warning to come again. So for that, we are importing this warning, and they can confuse the beginners as well. So that's why we need it. Okay. So warning are like my system will give me or my computer will share me the message that will say like something might be wrong here, right? So we need it because sometimes the warning are not that important and it can also like make us confused. So for that, we are using like import warnings like that. So warnings dot like here with you can see warnings dot filter warnings with ignore we have used. So it is like I am telling Python I don't want to show the warning message like that. So it will keep the screen clean and will help us to focus on writing the code without showing unnecessary warnings. Okay. So then we have used that sklearn pre-processing import min-max scalar. So min-max scalar actually helps to make bigger and smaller number into the same size. Okay, for standardization, we need min-max scalar. So this is actually, as you know, we have already discussed. Suppose the age is 20 and salary around 50,000. So my model will be thinking that salary is more important because it is bigger, right? So this mean max scalar changes the number of both age and salary into a range that is coming down from 0 to 1. So the smallest number will go down to 0 and the biggest number will come down to 1. So that everything becomes fair. So that my system don't give major importance to the number that is higher, right? So that is about the mean max scalar. Next we have imported sklearn dot decomposition import like from sklearn dot decomposition import PCA. So PCA is like packing a big suitcase into a small bag like that because PCA is like reduce too many columns and keeps the important information and also remove some of the noise from it. Okay, so that is why we are using PCA. So if you are having suppose all of this together, like suppose height, weight, age, shoe size, arm length, all of these columns all together, right? So PCA actually turns them into two or three smart columns that will take the work accordingly without losing any of the important information from it. Okay, so this is all about importing the library. So we have imported pandas, numpy, seaborn, matplotlib, gone down with missingo, warnings. Then we have mean max scalar and PCA. So pandas actually works with table like Excel as it is. NumPy is for doing the mathematical operations and calculations. Seaborn is making the charts beautiful. Matplotlib is to for drawing the graphs and putting it down on the screen. Coming down to Missingo, it is for finding the missing data. Warning to control the warning messages. Coming down to mean max scalar, it is for making the numbers paired for each of the group that we are having, and PCA to make the data smaller and smarter without losing any of the major or important information. Okay, so this is all about importing libraries. Now coming down to dataset loading, what we are doing in dataset loading. So in this section of code, we are basically connecting the Google Colab, like the Colab file, like the file that we are using, this Google Colab, to our Google Drive. Because in Google Drive, we have uploaded our data set there itself. Because sometimes, like, we can do one thing, like we can just go down here, and just a minute, it's connecting to the runtime. Just a moment. So it has connected. We can upload our data set using this, right? If we are creating this, then we are choosing the file, we are able to upload it, right? But the thing is, once the runtime, once there is a disconnection over the runtime, I won't be finding my data set over here. Then again, I need to re-upload, right? So that is a problem. In that is the reason we are trying to connect the Google Colab with the Google Drive to the folder specifically where we are storing the we are uploading our data set in the Google Drive. Okay. After that, connecting the Google Drive Colab file to the Google Drive, then we are finding the data set file and keeping the file path ready so that we can use it accordingly. Okay. So let's just go down to the code. So from google.collab import a drive, that actually says like I want to say like I want to use this Google Drive. Basically, I want to connect it with Google Drive. So from Google Colab, I want to import the drive. So Colab file like Google Colab is, suppose let's think Google Colab is your classroom and this Google Drive is the bag that you are carrying. Okay. So this line actually gives Google Colab the permission to open your bag. Okay. So that is the thing. So without this line, the Colab cannot see the files that are there in the drive. Right. So that's why we are using this. Now we are using drive.mount and we are using content slash drive, and we are force remount equals to true. Okay. So if we are taking it now, first we are just taking this content slash drive. This is the place inside the collab where drive will appear. Okay. So this is the place where my drive will appear in the collab. Okay. Now, where Drive will appear after this, the Google Drive will look like a folder, right? It will be looking like a folder. So the collab can read the file from it. Like if you can see from here, so you can see that is there are some of the hidden files. So it got some of the sample files. These are the sample files, but this is not the one, right? Basically, I need to take this content.drive. This is the place inside the collab where drive will appear, okay, where I'll get my drive. Okay. So once that is done, then we have this force underscore remount that is equal to true. So even if drive is already connected, we want to connect it once again. Okay. So why we are doing it? It avoids any kind of error. It ensures that is there is fresh and the clean connection. Or sometimes if I want to do it accordingly, I'll get it accordingly, right? So that is the case I want to do. So that's why I am use force underscore remount that is equal to true. After that, we are giving the path. So this path is basically where exactly the location of my data file. Okay, where is the exact location of my data file? So in my drive, I have a folder that is called heart disease. There I have this CSV file. So I have given the path accordingly. Like I have path is a basically the variable where I am storing the exact path, like how we have to fetch it there, right? So content underscore content slash drive that we need to give it, because content slash drive, this is the place inside the collab where drive will appear. So from there we need to go down to my drive, then I need to go down to heart disease folder, then I need to go down to heart underscore disease underscore uci.csv file. Okay, so this is how it is going. After this we will be just going for reading the CSV file. Now here we will be using pandas. Okay. Basically here what we are doing in this section, we are basically reading the CSV file, storing this in the table and making a duplicate copy for safe cleaning, right? For that we are using. Basically first we have used pd.read CSV with the path we are using pd dot read underscore CSV with the path, because path is the variable where I am actually storing the path where my data set is getting stored. Okay. Now, let's just close it. This is not required as of now. So this is the position. Now here, what is the CSV? CSV is of course this comma separated value. So it looks like a Excel sheet. So it has the rows and column, and read CSV, it means read this table from this file. Okay. So this is actually what it is. So path is actually where exactly my file is stored, that is giving me the reference. Now, DF is actually the data frame. So we have already discussed about data frame in the earlier sessions. Hope you remember about it. So DF is data frame. So data frame is just like a table. Now DF will contain the entire data set that we have, that this CSV actually contains, right? You open the CSV and you are reading the CSV using pandas and storing that table in like that CSV file, the content of the CSV file in DF, that is data frame. The data frame is actually a table where you are getting all of this together. Okay. Now you are using df underscore clean equals to df dot copy. So that means like we are making an exact copy of the data set. Okay. Because we won't be doing, we can do the processing over df accordingly, but there might be situations that we want this df back. Like we want to keep this df safe and secured, and we want to use this we want to do the operation in a copied version so that we can have the data frame clean at any point in time. If we need this original data frame, we can fetch that, right? So we are using df.copy that actually makes a photocopy, like the same content that df is having. So it is separated from the original one and we are using it, we are taking the copied version of it. Okay. Now coming down to print df.columns to list. So this is actually to list means we are taking it, we are seeing or looking and understanding if my data, like whatever the columns that I am having in my data frame, that is exact the same in the in the file that I have copied it. Of course, it will be same because it is copied. Just for a reference and making you understand that this is a safer way to do, I have done it. Okay. So I have just enlisted the column name up here for the exact data frame, that is the DF that we have and the copied version of the DF. The name of DF, the copied version we have given DF underscore clean. So we can see that everything is same. There is no problem with that. And we have also counted the number of columns. So we have got 16 columns in total. So here you can see that total columns is 16. That total 16 columns only we have taken here. Okay. Now, this is done. We will go ahead with this part is done. Now we want to go ahead. We want to find out the first five rows of the data set we want to see. Like this is my raw data set. I haven't done anything with my data set. I have just read my data set into a data frame format, like a table format, so that Python can read it and I can do the major task up here using this. Okay. Now you can see the first five rows of the data set and all of this you will be visible. Like this will be visible. Like this is how my data set is looking, like my raw data set, right? Now I want to see what is the number of rows and what are the columns that we are getting. So here you can see the number of rows is 920 and the number of columns is coming out to 16. Okay. Now coming down to dataset information. So dataset information, we are using df underscore clean dot info. So here we are basically checking how many rows are there, how many columns are there, what kind of data is inside each of the column, and what are the missing values. Like, are there any missing values? Like that we are trying to check. Okay. So we are doing df underscore clean. So this is my cleaning copy of the data set because here all of the processing we will be doing, and dot info, that is an inbuilt function that Python have, so that actually says I want to like tell me about, like I am about telling this data set, like tell me about yourself, like that I want to see, like this is the information that I want to get, like how many rows are there, how many columns are there, this updates I want. Okay, so this is giving the number of rows, like sorry, number of columns, what are the column names basically, what is the record for each we are getting, and we are getting is like we are getting not null, and accordingly the data type accordingly, like what are the data types that we are getting. So here you can see the data types are majorly of float, accordingly to int to object, like that. Okay, so this we have got accordingly. So after this, we'll move ahead. We want to see is there any duplicate values there or not. So for checking that, we are going ahead with df underscore clean dot duplicate dot sum. So basically here it will count how many rows in the data set are repeated. So like df underscore clean, as you know, this is the cleaning copy of the data set dot duplicated, this this part basically dot duplicated, this part actually it simply means like I want to check the data, like exactly like how many rows I am getting that is exactly same, right? So we are checking for that, and like it will just take it accordingly, it will mark as true, like if the copy is, if the row is getting copied in the earlier row, like is it exactly same, then it will be giving me true, else it will be giving me false, like that it will be storing. And once we have stored it, we are using this sum operation to get it accordingly, right, to get it accordingly. So sum is actually just taking the like it will calculate the true, how many true returns we are getting, that it will be calculating. Okay, so let's just go here and show you. Okay, let's just take another file. Suppose I have the row and I have the column, like it is the name basically, and I have the age. Sorry, age. Okay, so hopefully this is visible to you people. Row is here, it will be giving me the row number, the name, and the age, right? Suppose the row number is 1, 2, and 3. And the name is like, suppose Tom, Anna, and again Tom. Okay, and the age is suppose 10, and 11, and 10. Okay. Now, if you can see here, we have used dot duplicated. So dot duplicated will return us the value as this one is false, because this till the point my predefined function duplicated has checked this is unique. There is no duplicate it has found before. So it will be returning me false. Of course, for this, it will be returning me false. Okay. And for this, you can see it is the row number, it is 3, but this content is similar. Tom and 10. The name and the age is similar. So it will be returning me true. Okay. So it will be returning me true. So I have got row 3 is duplicate of row 1. Right? Row 3 is duplicate of row 1. So duplicated will give me this kind of value like false, false, and true. Okay. Now what we are using up here, we are using dot sum. Okay, just a minute. Dot sum we are using. Why we are using dot sum? So we are using dot sum. This is a predefined function sum, as you all know. So this actually adds up all of the true values that we are getting. Okay. So basically what we are going, so false would be taken as 0. Again, false, we are getting it as 0. Then true is getting as 1. Because my system is understanding, like it is understanding number, right? So it will be stored in this way, 0, 0, 1, like that. So once I am now calculating, so I will be calculating 0, like I'll be doing sum 0 plus 0 plus 1, right? So it will be returning me the value 1. So it will be returning 1 is duplicate. Okay. So hopefully you have understood how this part is going. So let's just go here. Yeah. So this is the duplicate value, like this is how it is going accordingly. Okay. Now, this is basically the sections that we have done. So duplicated actually find the duplicated rows. So we and returning it true. This row is like when we are getting true. So this means this row is copied. False, if we are getting the false value, then this means this row is unique, like that. And sum is actually counts the duplicate value accordingly. Okay, so this is done. After this, we are going down, and here you can see. Sorry, yes, here basically. So here you can basically see that it is returning the output that I am getting. It is getting input dot np dot int 64 that is giving us 0. np that is basically np is numpy and just a minute, dot int 64 that is basically the data type, that is integer type, and it is giving me 0. So 0 means there is no duplicate value that I am getting over here, right? So we are using sum and we are getting no duplicate value up here. So this is doing good for us. So since there is no duplicate value, it is very easy for us to work with this data now. So we don't have to tackle this duplicate value. Okay. Now coming down to missing values or null values. So missing values and null values, basically what we are getting up here. So in this section, it will check every column and count how many values are missing for each of the columns. Okay. So if I am taking this data set, so this is my data set, I'll be getting I'll be getting over there. Like this is a similar kind of, not similar, just to make you understand, I am using this data set. Now you can see this is the data set. So how many columns inside index, how many would be missing? That number it will be returning me. For order ID, how many number of rows or number of cells basically it will be giving me like it will be vacant or there is no value at all. It will be returning me that. Okay. So going down here, yeah. So you can see about how many missing values you can get, that will be getting it. So I have ID 0, age 0, like here there is no missing value. I have got missing value in T-res BPs, that is 59. For cholesterol, we are getting 30. For FBPs, we are getting 90 missing value. We have guessed rest ECGs, we have got 2 missing value. Thal CH, we have got 55. Angina, like exercise suppressed angina, that is giving us 55. Old pick is giving us 62. Slope is giving us 309. CA is giving us 611. Thal, it is giving us 486. Num, there is no missing values. Okay. So this is all about the structure, like the content of the missing values for ID, age, gender, data set, CP, and going down to num, we don't have any missing values. All of the records inside this column are full. There is no missing value up there. But from TRES BPs going down till thal, we have got all of the missing values of different numbers. Okay. So here going down, we have df underscore clean dot is null dot sum. What we are doing here, so is null basically, like this function in Python, this actually checks if the value is missing, blank, or NaN. NaN is not a number. Okay. So accordingly, as I told you, in case of duplicated, like the same, it will return us true or false based on, suppose this is blank, and this will return us true, and rest, this is again false, and this is also false because it has checked accordingly, like it will be checked for based on each and every column. Okay, each and every column it will be checked, and based on that it will be returning, right? Like this, for age, if I am checking age, this is blank, so it is returning me true, and this and this false. For name, there is no missing, it will be returning me all false. For row, nothing is missing, it will be returning me all false. Okay, so like that, it will be returning. After that, we are doing dot sum again. So dot sum, what is the number of true values I am getting? So it will be just counting it off. So true will be 1 and rest will be 0. So again, I'll be doing 1 plus 0 plus 0. So it will be giving me 1. Okay, for all of the column, I'll be doing like that. After we have got it, so for this column, I'll be doing the summation. For this column, I'll be doing the summation. For this column, I'll be doing the summation. So for column wise, I'll get the data accordingly. Okay. So this is how I am doing for missing values. So once this is done, we'll just move ahead. Okay. Now I want to see the missing value. So this is mandatory, guys. Make it clear that whenever we have just identified that this number of values are missing, we need to view the missing values, like how my missing value actually looks. Okay. So I need to view it. So viewing it, I'll be checking it accordingly. So I want to view my data accordingly. Yes. So if you can see, I have used the Missingo matrix. So I have already previously, in case of libraries, I have already imported Missingo, import Missingo as MSNO, that we have already done. So now is the time to use it. So here you can see uh, we have used accordingly. So we have used MSNO dot matrix df underscore clean. So what we are doing up here, so we are basically here we are using this matrix picture. So this is the matrix picture, that is the lines and the blocks that we are getting. So this is actually drawing to show which data is missing. Okay, so each of the vertical lines, like one of the column, that is the vertical line, and each of the horizontal line is representing each of the rows. Okay. So now basically this white lines, if you can see here, so that is actually giving us the missing values. Like this is giving us the missing values. So it can give you, like for ID, you can see that there is no missing value, age, no missing value, gender, no missing value, then data set, no missing value, then CP, no missing value. But we are getting missing value for TRES, BPs, cholesterol, FBS, like this. So here, if you can check ID, age, gender, data set, CP, no missing value, but here we are getting the missing value. So that exactly we are visualizing. Okay. So this is basically we are visualizing using this. So Missingo is the Missingo matrix. This is actually drawing and showing the data that is missing. So this is actually filling the seats like that. Like it is like filling the seat like that. So if the seat is filled, so we can say that is the student is present inside the seat. If the seat is empty, we are calling that is the student is absent. The same way, so if the data is present, so we are calling that is data is there. If the data is missing, in that case, we are saying that there is a missing value. Okay. So the same way we are using this missing go, then we are using the heat map. So the same way we are using the heat map to visualize the data using heat map. So basically why we are using heat map. So heat map basically giving us the presentation accordingly, like the color wise presentation we are getting. Here you can see the black and white. So here it is colored. So we are getting a color schemed visualization. So it looks at the line and break it accordingly. So accordingly we can see it. Now we have to understand the variables, what each of the variables actually tells. So for this, first we have taken the data set columns, like what are the columns that we are getting, what is the name of the columns, and what is the data set of the like data types of the column. Okay. So we have taken the df underscore clean dot column. So it is giving me all of the name of the columns because we need to, these are my variables basically. These are my variables that we need to take accordingly and we need to work with this. So we need to understand each of our variable very well so that it is clear and we can understand each of it in a better way. Next, we have used d type. So that is giving me the data types. So for each of the data like the column name, it is giving me the data type. So the column name ID has the data type integer data type. Age is an integer data type. Gender is an object data type. Coming down to data set, it is a object data type. CP is an object data type. T-rest BPs, it is a float call that is cholesterol basically that is giving the float data type. FBS that is an object, REST ECG that is an object, HAL C8 it is a float, X angina that is giving us exercise accustomed angina that is basically giving the object, old peak that is float coming down to slope that is object. CA is like float, again thal is object, num is integer. So this is the data type along with the name of the column that we are getting. Okay, so now we are going for dataset descriptions. So dataset description actually what it is showing, it is shows some of the important statistics. Okay, so important statistics about the dataset, like what is the average, what is the minimum, what is the maximum, how spread out the dataset is. So that is, so first we are printing this line that description of the dataset. So in the output you can see we have got this updated the description of the data set. Now we have got df underscore clean dot describe. So it is for each of the, like of course the description will come for only the numerical columns, right? For categorical column, we can't find out the mean, we can't find out the quartiles, that is 25% of the data, 50% of the data, 75% of the data, also the mean count, this we can't get, right? So that is this description is specific to numeric column that we are getting. Okay. So here you can see it for ID is a numeric column like integer basically integer column. So here you can get so here if you are counting 1, 2, 3, 4, 5, 6, 7, 8. 8 we are getting. So here you can see 1, 2, 3, 4, 5, 6, 7, 8. 8 values like 8 columns I am getting whose data type is integer or float. Basically numerical data type. In that case, we are getting the values accordingly. For count, the ID based in the ID column, what is the count? What is the age? What is the for age? What is the count? What for TRES, BPs, what is the count that we are getting for all accordingly. Count, mean is the average one, standard deviation, it shows us how spread out the numbers are that it is showing. Minimum, like the minimum value, next coming down to 25% of the data, 50% of the data, 75% of the data we are getting. This is basically getting the median values basically. Like 50% will give me the median of all of the data that we have got. 25% we have got, that is basically the Q1, that is quartile one. That is for the upper range, like the lower data that we are getting. So for that lower data, what is the median? And for this is the after the middle value, the next half value that we are getting, what is the median for this? That value we are getting accordingly, and also getting the max value. Now we want to get the variable descriptions. So what are the variable description that we want to check? So variable description, basically variable description. Okay, variable description, yes. So we want to check what are the unique values that we are getting up. Okay, so we want to check, like of course we have first printed unique values in each of the column of the data set that we want to check, because we have checked for the duplicates as well. So the similar way we will be checking the unique value. So uh, n unique is a inbuilt function that is there inside Python basically. So n is the number basically, and unique is different or the unique values that we are getting. Okay, so n unique totally, like n unique in total as a function gives us the number of different values or number of unique values that each of the column is getting. Okay, so IDE, like initially for duplicate, what we have done, we have used the function that is n, we have used the function duplicated, and then we have summed it accordingly, right? Now here in case of this, you can see that we have taken it accordingly, and we have used that n unique. Here n is the number and unique is the like the unique values that we are getting. So we are doing all of that purpose, like getting the numerical up like output using a single function. Here that is why there is no need of using dot sum. We are already using n, that is the number, so it will return me as an output as a number. Okay, so you can see here all of this, like id, for id the number of unique value is 920. That is exactly the number of records we are having in my data set, that is 920. Coming down to age, there is 50. For gender, we are getting two unique values. For because with gender we can see it is two, that's why we can easily tell that this is a categorical column, and the data type is object type. Coming down to data set, it is 4. Of course, for this also we can say, then TRES BPs, it is 61. For cholesterol, we are getting 217. For FBS, we are getting 2. For REST ECG, we are getting 3. For HAL CH, we are getting 119. Next, for exchange, like exercise induced angina, that we are getting exercise induced angina, that we are getting 2. Old pick, we are getting 53. These all are the unique values. Okay. Slope, we are getting 3. CA, we are getting 4. Thal, we are getting 3. Number, we are getting 5. Right? All of this we are getting. Now we are up to this, we have understood our data set properly, what each of the column is making us understand, what is the data type of the columns, and based on that, what are the variables that we want and how it will be looking forward. Everything we have understood, right? Now we'll go forward with the data wrangling process, like data cleaning process. Okay. Now coming down, we have to first check for removing the exact duplicate. We have already checked that there is no duplicate. Okay. Then also we are just checking it up, like we want to understand it here and we want to just take it here, for because as we have mentioned, all of this are the steps that are needed for data wrangling. So the duplicate value we have already checked, and in the initial cells basically, there we have already got as an output that there is no duplicate. So if you want, you can skip this part as well because we have already checked. But just to make you understand and just to follow all of the steps that we have discussed accordingly, I have included this part. Okay. So data wrangling step. Step one is, of course, coming down with removing the duplicates. So here, basically, what is our goal? It is to check if the rows are copied, like duplicated. I will be counting how many duplicates do exist. Then I'll remove those copied rows, that is the duplicated rows, and will check for the new size of the data set. Okay. So here we have first what we have done. So first we will be finding the copied rows, then I'll remove them, then I'll check the final size. This is my task that I need to do here. Okay. Now here, line by line, if I need to go ahead, so you are here, you can see I have used print checking for duplicate rows. So this is what action I am doing here inside the data wrangling process that I have mentioned. I have just printed it in the output so that it's clear for every user who will be taking, like who will be getting this. Suppose anyone is getting this collab file, so they will be understanding that in here what we are doing, we are checking for the duplicate rows. Okay. Now it is very simple. So this line actually prints the message on the screen that checking for the duplicate rows. Now here we are using that is slash n. This is actually meaning the new line. So it will like after this line I have written, I'll press enter and I'll then print the rest of the thing. Okay. Next I have printed duplicates found. Okay. So what are the duplicates here? I have stored the sum, so it will be giving me the count actually. Okay, so it will be returning me the value. So here, as we have already checked the similar way it will be checking it accordingly, as I have told you. So same operation will be performed here. And once that is done, it will be returning me the value. So here you can see it has returned me the value as 0 because there are no replicates in my data set, right? Now we have used df clean dot equal to df underscore clean dot drop duplicates. So drop duplicate, this is actually like it is like I want to delete the extra copies. Okay, so we assign back to df underscore clean. So Python does not change the data set automatically. We must have to save the clean version. Okay. So for that, we are just using this df underscore clean dot drop duplicates. So that actually taking me and dropping all of the duplicates if there is any. So since there is 0, nothing has been duplicated, like no duplicate has been found, and we don't have to drop off any of the duplicate. If there is the value is 10, then we will be dropping all those 10 values that we have got, 10 rows basically that we have got. After that, we want to find df underscore clean dot shape. So this shape actually means the number of rows that we are getting after removing the duplicate and the columns, right? So the column will be staying intact because we are checking for the rows in what case as well. So if the value, this duplicate was found around 10, so my original is 920, it will drop it down to 910. Okay. So this is how I have performed the first step of data wrangling, that is removing the duplicate. Okay. Now coming down to fix the inconsistent entries. So here the very first logic that we will be taking, that is inside this, like I have a wrong spelling. The wrong spelling is Reversabledefect. So reversible defect, this spelling is wrong, but the correct spelling is this. So I have this value inside this column, that is thal. Inside this column we have this values as reversible defect. This value is also there and this value is also there, like as we have taken initially. Like if we are going up here, Here you can say we have the women, we have W, we have men, and we have, just a moment, let me just get the filter. So here you can see we have M, we have men, we have W, we have female. So it is taking everything separately. Actually, M means men only, W means women only. So we have to take it accordingly. So we have taken it accordingly here. And now you can see, okay, not here, just a moment. Let's just clean this part. Let's take it here. Here, actually, we have cleaned everything. So here you can see that here you have got men and women accordingly, right? You have got men and women. So here also we are getting. So we have to replace it. So we'll just replace this. So we have got here. So just a moment, let me replace it. So this is I am doing in Excel, but this you need to do it in case of Python. Like we will be also seeing how we will be doing it in Python. Okay, so it has replaced all, and now if you are checking for all, then you can see men and women, right? So similarly, here also in my data set, I have got reversible defect, this value as well, and reversible defect, this value as well, right? But this is the correct spelling and this is the wrong spelling, right? So I'll be changing this with this updated, like I'll just update this with this value. Okay. So here, our goal is to find out the wrong spelling. I want to replace it with the current spelling, and I'll make all of the entries consistent. Okay, so this is my work up here in this stage of fixing inconsistent entries. Okay, so now if I am going down here first, what I am doing, I am just printing what action I am doing. I am just fixing the inconsistent entries, so this line actually prints a message on the screen like now I am actually fixing the mistakes in the data, this kind of statement. Like here I am giving the statement as fixing inconsistent entry. So this will be displayed in the output. So here you can see this has been actually displayed in the output. Okay. After it has displayed accordingly, you can see here that what we are doing up here. We are using df underscore clean thal. This we are taking. So this select the thal column from the data set. Basically, this this defect is there. Like this like inconsistency in the data is having in the thal column, right? So here also, since we have here also, if you can see here, the inconsistency is there in the gender column, right? So what we have done to do it, we have just first selected the entire thing. So we have just done it from here. So we have just unselected all and just selected M and I want to view it, right? So we have to select this column. The operation would be happening in this column only, right? So we need to select it. So that's what we have done here. So we have first selected the thal column from the data set. So this data set is like the cupboard basically, and thal is like one drawer. So inside the drawer, there is the inconsistency, right? So I need to pull the drawer. Like if I am just showcasing the entire data set, there would be a difficulty. So I need to showcase the drawer, right? Next, I have a dot replace. Here, I want to replace irreversible defect with we have to replace reversible defect with this incorrect spelling with this correct spelling. Okay, so this is my old value and this is my new updated value. Okay, so this actually give us here only. This is my value where I will be storing this. This is my column where I'll be getting it, and here I'll be storing the updated value. Okay, after it has replaced, after this value has replaced with this value. Okay, so here it will be stored automatically. Okay, now we what we are doing up here. So we are just going ahead with this, and we are using this. We are using this to go with it. So replace is basically fixing the spelling. Okay. So replace is like I want to replace this value with this value, right? So this is the fixing the inconsistent entry we have got like that. Now we are moving ahead with the third step, that is handling the missing values. So we have got so many missing values up there. So we want to handle it. So basically our goal is that, so we have this numerical column, we have this categorical column. So as discussed in the earlier sessions, the earlier session we have already discussed, there is a difference when we are handling the numerical column, the missing values in the numerical column and the missing values in case of categorical column, right? So here we are first enlisting the numbers. Numbers basically we are filling the empty box with the median value in case of numerical column, and in case of categorical column, that is the word specific or text specific column, that we are filling up the missing values that are coming in case of this categorical column, we are filling up with the mode value. Okay, we are filling up with the mode value. So here you can see that we have first printed what action we are doing, handling missing value. So here you can see we have got the missing values, like handling missing value. So now here after that, what we have done, we have used like num columns and enlisted all of the numerical columns. So if you go up here, just a moment. Yes. These are all my numerical columns in the description, because the description will happen only for the numerical columns. So here I can enlist all of the numerical columns and understand these are my numerical columns. Also, we can get the numerical columns using like understanding about the data types, right? But here it is much easier to understand because this describe function only work for the numerical column. So this all are my numerical column. So what I am doing here, so I am enlisting all my numerical columns here. So this actually makes the list of the number columns or the numerical columns. So these columns are blood pressure, cholesterol, heart rate, and like old pick, CA, like this. Okay, all of this. Now I am using for call, like we are taking any or like the columns like that in num column, like for as we are using for I in this. So here in place of I, we are using call. Okay. So for call in num columns, so it is like going through each of the columns of the number list one by one. Like it will check the T rest BPs, like if you can see, the first one is T-rest BP. So it will check first T-rest BP, then it will go to cholesterol, then it'll go to thal CH, then it will go to old pick, then it will go to CA. Okay, like that it will be moving. Okay, then we have used what we have used df underscore clean call dot fill na, and used inside it we have used df underscore clean call dot median. Okay, so now let's break it accordingly. So we have used fill na. Fill na is like filling the empty spaces. Okay, I want to fill the empty spaces. Next, I have got median. Median is like the middle value, right? So if we have 246, in that case, 246, three values are there. So 4 is the middle value. So it will be filling up with 4. Okay. So this is actually we are taking it accordingly. So we are just taking df underscore clean column. They like here in this column, suppose we are taking for T-res BP. So for T-res BP, what are the missing values I am getting? That I will be filling it up with the median actually. Okay, with the median value we will be filling. So this is the work of the numerical column that we did. Next, coming down to the categorical column. So we have used cat underscore column and cat underscore calls. Basically, this is the variable we have chosen. Now this actually creates the list for all of the categorical column we are having. So any of the other column, irrespective of this, will come for the categorical columns, right? So we have the column as FBS, REST ECG, we have X angina, then we have slope, then we have TAL. All of this we are getting, right? Once we have got this, again the same way we are using for call in cat column. So each of the column it will be going first, it will go to FBS, then it will go to REST ECG, then X angina, then slope, then thal, like this it will be moving. Okay. So now we have inside it the mode basically. So mode is basically we are giving the most common value. So if suppose my in any of the column, my data is being stored as yes, yes, and no. Like if I'm going here, if suppose this is the column, like any of the categorical column, and the values are stored here as a Boolean type, that is true, false, false, right? So you can see that here I have got one true and two false. Like here it has been mentioned zero. So for one, if I am counting the true, that is the count would be one. Okay. And for counting this, the count would be two, right? The count would be two, right? So if I'm comparing this with this, so I am getting two is bigger. So it will be returning me this value false, false as my mode value. Okay. So false as my mode value. Just a moment. Yeah. So this is how we are doing it, and why we are giving this zero. Zero is sometimes that can be more than one mode, right? So there can be possibility that we have, like, suppose for true, yes, no, maybe. Like if we are having the value as yes, no, and maybe, and it is storing like that, we are getting the value as one yes, two no, and two maybe, right? Like this, if we are getting, in that case, the mode value is two, right? Like two mode values we are getting no as well and maybe as well. In that case, if we are getting here zero, if you can see like this one, zero. So that will actually, like we will be taking the first mode one. We will be choosing the first one to fill the empty cell. So in that case, no is coming first. So the empty cell will get the mode value as no. Okay. So this is about the categorical column. So this is how it is getting. After it has been done, now I am printing like missing values left, and I am counting for the missing values. Again, the same way is null I am checking, and then I am doing sum dot sum. So it will count all of the missing value in the whole data set. Okay. So the missing value left we are getting as zero because we have performs this operation over the data set, over my entire data set, and accordingly it is giving me the values accordingly. Okay, so we are getting the values like this. Now I want to treat the outliers. So this is done. Now my fourth step is to treat the outliers. So basically, you know about what is outliers. Suppose I am giving an example that there are students whose height is 140 centimeter, 145 centimeter, 150 centimeter. Suddenly you get a entry of the student height as 500 centimeters. That look too strange and absurd, right? So this is not matching with the above values because that is around 140, 145, 150, but this value is 500. So this is way too much. The difference between this outlier with the other values is coming more, right? So that is why we are considering it as outlier. So here in this case of detecting and treating outlier, our goal is to find the values that are too small or too big. Then we need to decide like is they are normal, or like decide they are normal or not normal basically, right? After that is done, then we will replace them with a safer middle value, that is the median value we will be doing. So first we will be finding the strange value, then we will be fixing them and will make the data normal. Like that, this is my task. Now, as usual, I am printing what task I am or what action I am performing, detecting and treating outliers in my output so that we can understand that it has worked accordingly, and we are also understanding what action we have performed. Right now, of course, slash n already discussed. This is the like parsing to the new line, like the next print that we will be taking that will come down to the new line. Okay. Now, here we are using like numeric columns equal to df underscore clean dot select data types, including like include equals to np dot numbers. Next, we are using dot columns dot toList. Okay. Now, taking it accordingly. So, select underscore d types include with np dot number. This means select only columns that have numbers. Like I want to ignore the the categorical column that has the values like male, female, yes, no. The categorical column I want to remove, and I want to include only the numerical columns. Okay. Now, dot columns to list actually returns us the column names into a list. Okay. So it is giving us the column names into a list. This is one way of doing it. Here also we have done just enlisted all of the column names. We can do it like that also. That will also work. The same thing. Okay. No issues with that. Now we will be running a loop. So the same way. So it will be using for column in numeric columns. In numeric columns is a list that will store all of the numerical columns. Okay, like this one. Yeah, this one. So we will be getting T-rest, BPs, cholesterol, thal CH, old fake CA, all we will be will be getting. Okay. Now, after we have done this, next we are taking QA df underscore clean call dot quartile 0.5. So we will be finding the 25% point, like 25% of the value are below this number. So first quarter we will be getting. Similarly, we will be finding out the Q3, right? Then I need to find the interquartile range. So for that, I'll be using IQR, that is equal to Q3 minus Q1. That we have already discussed in the last session, how we have to find out the intra-quartile range. If you haven't watched that, just go ahead for the previous session. Okay, there we have discussed how to detect the outlier using IQR method. So this is the simple IQR method that we are using. So we have found out the interquartile range. Then the similar way we have found out the lower bound and the upper bound. Okay. So once that is done, we have gone ahead with median underscore val, that is df underscore clean call dot median. So what we are doing is this find the middle value. So we are taking the median value, because why we are taking this median value, because this is not affected by very bigger or very smaller value. So it is the safer choice to take. That's why we are taking it. Okay. So now we want to replace it. So in that case, we are checking like if this value that we are taking that is lower than this lower bound, in that case we will replace that with the median value. And if all of this value that we have stored in df underscore df underscore clean in the call here, basically like this call is basically for the loop one that we have taken the call. So that is greater than my upper bound. That will also be like basically the values that will be like lower than the lower bound and upper much more bigger than the upper bound. They are my outliers actually. Okay. So we will be finding that, and based on that, we will be replacing that with the median value. So this is the work that we will be doing. Now, after that, we will be moving down to the scaling part of it. So basically, all of this function, like all of this part, we will be doing. So after treating the outliers, we will be doing for the scaling and normalization. Okay, scaling and normalization. Basically, what is the logic up here? So as you know, suppose we have the column for an example, height. Height is coming around 100 to 200 centimeters for all of the students, and weight is coming out around 30 to 100 kgs, right? So the height numbers are much more bigger and the weight are much more smaller, right? If you feed this numbers directly to my model, the bigger number will be, of course, dominating, right, to the model, and my model will get confused, and we won't be getting the like the predictions what my model will giving, that won't be accurate, right? So we want to just replace it, like we want to scale all the numbers in the same range, and the range would be from 0 to 1, right? So this is our idea that we want to do. So we will be scaling all of the numbers to the same range of 0 to 1. Now, next we will be make sure that no feature is dominating henceforth, and we will, like we are getting a fair chance for each of the features that we are looking into. And after that, we will be keeping the relative difference intact, and then we will be moving ahead. Okay. So we are actually shrinking the numbers. Like you can think it of like that. We are shrinking the numbers to a fair, to get a fair choice. Okay. So this is how we are going. So of course, we are first printing what function we are doing, like what action we are doing, what action we are performing. So we are actually doing scaling the numerical features. So scaling is basically happen on the numerical features. As you know, the numerical features that we are getting, that is having the major defect, like defect in the sense the issue with the range. As the numerical columns like height, weight, they are numerical, right? So we will be getting the things there itself. So that is the reason we will be doing the scaling in the numerical columns only. Then scale underscore call is giving us column for call for call in numerical column if call not in ID and num. Okay. So what we are doing? Numeric number is the list of all of the number column. Okay. Now if call not in ID and number, so we are just keeping these two columns, ID and number. Okay. So ID are just the labels, like not not the features basically. So we are like we are just not we are not taking into that. So the rest of the numerical feature columns we will be taking. The num and the ID we are just taking. Num are actually the features and ID are basically the normal IDs. So that we are just taking it up. Okay. So that we are skipping, the rest of the columns we will be taking accordingly. Like numerical columns we will be taking. Okay. Next we are using scalar equal to mean max scalar. Okay. So it is like simply creating the tool called mean max scalar. So we have already discussed about mean max scalar in the last session. You can just go ahead and understand about what is mean max scalar. So I'll just give you an idea. So it actually shrinks the number in the range of 0 to 1, and how it do it and what is the formula that you can go down and check in the last session. Okay. And after this, we are just using scalar dot fit transform, and we are giving it accordingly. Okay. So scalar dot fit transform, like fit function is actually find the min and the max for each column, and transform actually scales the value between 0 to 1. Okay. Next, a df underscore clean scale column, that is actually save the scaled number back to the data set. This. Okay. So this is how we are doing the scaling. So this is done. Now we are going ahead and doing the encoding. So basically, male and female, these are the genders. And of course, we have got CP, dataset, all of this numerical columns. So basically, what we want to do, we want to convert the word or the categories into numbers, because my model won't be understanding the categorical value or the textual value. So we will make each of the category into a new column. We'll use 0 and 1 to show the absence or presence. Okay. So first we have just taken the action, like printed the action that I want to do. Next, I have used all of it. So we have, you can see pd.get dummies. So this actually returns the categorical column, like words like male, female into new columns. Like I will be getting, like, suppose let's go here. Okay. Suppose I have the column as gender. So the values that are storing up here is male and female. Okay. Now what this get underscore dummies do, it returns the categorical column into new columns. Like this, we will be getting, this is the value. So we will be getting the new column as male and female. Okay, and accordingly storing the value as 0 and 1. 1 means, suppose for this column the result is female, so it will be giving 1, and the male is 0, so it will be giving me 0. Okay, or male 1, female 0, like that. Okay, so based on the content. Now going down to here we have columns. Columns is just the list of the columns, the categorical columns that we are having. Okay, so we have enlisted that. So only this categorical columns will get converted. Okay, now I have used drop underscore first equals to true. So what it exactly do when encoding, like it actually what it do, like when encoding, if the column has like n categories. Like n column will be created by default to avoid the redundancy, like the multi-collinearity, we drop the first column. Okay. So basically, suppose the like how to tell, uh, let's have like the gender. It has two options like male and female, right? So normally two columns. You can see two columns has been created, male and female. Right. So what we are doing, we are dropping this male column because here, like if it is 1 and this is 0, of course. So if it is 1, of course, it is found that for this row, the record is for female, right? That is not male. And if it is 0, we can definitely understand that in that case, the result would be for male, not for female. We will be understanding. So we will be dropping off this one. Okay. So from one column only, we will be able to get the details. Okay, so we are dropping the first and we are returning it true. So now df underscore clean, that will save the new recorded data set back to df underscore clean. Okay, so the older values, like the older column, are replaced with the newer 0 or 1 inside the column. Okay, so this is how we are doing the encoding. Now coming down to the feature engineering, we are doing some of the feature engineering over the data. Okay, so we are doing the feature engineering. So that actually we have the age, cholesterol, and the number of heart disease, that is num, as as the values altogether, right? So here basically what we want to do, we want to make a like target column that would be binary. If we are getting 0, that means no heart disease. If we are getting 1, that means there is a heart disease. Okay. Next, what we want to do, we want to create a column that will give us the age category, like the age column we will be getting, or age group we will be getting basically. Okay. So this will group the age into categories, that is young, middle age, senior, like this. And then we want to create a new column that combines the cholesterol and the age together, and will encode a new categorical column that so that my model can read them accordingly. Okay. So basically what we are doing up here, we are using this df underscore clean heart disease, and using equal to df clean num, if it is greater than 0, age type and int we are giving. Okay, so basically if num is greater than 0, we are giving 1 as an return. So that means that it has a heart disease. If the value of num is equal to 0, then we are getting the value as 0, that is no heart disease. So df underscore clean num that is greater than 0, that actually checks each of the row and return is at true. If true is there, so that means it is heart disease exists. If false is returning, that means no heart disease exists. Okay. Next, dot as type int that is actually converting true to 1 and false to 0, so that we are getting the numerical value, because my model will understand the numerical value, not the categorical, like not the categorical values, right? So it will understand the numerical value better. So we are converting it to 1 and 0. Okay. So this is about the binary target column. Coming down to the age group, so we are creating specific age group like young, middle age, senior, like this. So here you can see we have used df underscore clean, then we have used the age group, and we have used pd dot cut. So basically what we are doing, we are dividing the age into three groups. Young, whose category is going from 0 to 40, middle age 41 to 55, and senior is going to 56 to 100. Okay. So pd.cut, it actually cuts a continuous number column into categories. So here you can see bins, we have used 0 to 40, 55 and 100. So it is taking it accordingly 0 to 40, 55 and 100, young, middle age and senior. So anyone with age 35, it will be giving as young. Anyone with age, suppose 50, it will be giving us at middle age. Anyone with age 60, it will be giving as senior. Okay. So basically, we are getting the range from 0 to 40, 41 to 55, and 56 to 100. This all are the range that we are getting. So after that, we are just encoding the age group. So we are using df underscore clean that is equal to pd dot get dummies, like here. So this will turn the age group into 0 or 1 column. So we'll drop the first one. So here basically we will get three different columns, like age group with middle age group with senior, like this we will be getting. So it will be changed into 0 or 1, like this we will be getting. And the first one we will be removing. So after we have removed the first one, we will be getting the age group of middle age group of the group senior, like that we will be getting. Okay. Just for a reference I am telling. Now about the cholesterol per age ratio. So that what we are doing, we are creating a new feature, like this part basically we are talking about. So here we are basically creating a new feature, that is cholesterol per age. So why we are taking plus 1 as the denominator? Because to avoid divisibility by 0, that's why we are taking it like that. And it will be telling us like higher cholesterol relative to age, like it may indicate the higher risk, or it may just what is the correlation that it will be giving. Okay. So basically we have taken it accordingly. So here we have taken three columns. Basically we have got first the heart disease, that is 0 or 1 targeted column for the machine learning model. Next we have got the age group, that groups the age into young, middle age and senior, and we have encoded the age group that will return the categories either 0 or 1 for the model. And then we have taken cholesterol per age, that is a new number that combines cholesterol and age. Okay. So that we are getting. So this all are the feature engineering we have done. So after that, we want to drop it off the num column. Basically, like we want to drop off the num and IDE column. Why we are doing it? We are doing it because that is actually giving us like that is not required for us anymore, because from num column, we have already created the heart disease column. So it is going good for us. So now we have dropped off all of it. And now we have figured out and finally seen the final data set, how my final data set looks. Okay. Okay, this I don't want. I want to delete it. Yes. So this is my data set. This is how my data set looks. So you can see the heart disease. It has giving me the result as 0, 1 or like that, which is giving me. And accordingly, the values we are getting as hungry, not hungry, like that, age, like that. This is how we are getting the values all over. Okay. After this, what we are doing after dropping it off, we are just finding out the target distribution. We want to get the target distribution. Here, basically, we want to count how many values we are getting for how many values for one we are getting, like how many values we are getting for heart disease and how many counts we are getting for no heart disease in my entire data set. So we want to understand if the data set is balanced or not balanced. Okay. So here, after this, you can see that we have just taken, like have printed this line. So what action we are performing, that we have done. And after we have taken the value df underscore clean with the column name. The column name is heart underscore disease, and we have used dot values underscore count. So this actually simply count how many zeros and ones are there inside the heart underscore disease column. Okay. So values underscore count is giving us the exact number of count that we are getting for one and exact number of count that we are getting for zero. So it is giving me the output. So for one, we are getting 509 and for zero, we are getting 411, right? So we can figure out there is no class imbalance. So we need to check the class imbalance because in that case, suppose in my data set, the data we are getting for heart disease is suppose 500 and for no heart disease the data is around 10 or 11, right? So there is a major class difference in that case. So in that case, we need to handle it because if we are keeping it like that, we are not handling this. In that case, when we will be just going down to the model, and my model will be learning from this data set. In that case, what will be happening? My model will be unable to predict it correctly. What the prediction my model will give, that it will be unable to do it because of this class imbalance. Okay. So we in that case, if there is a class imbalance, then we need to handle it. But here we can see there is no class imbalance. It has taken it accordingly. For number for one, the number of heart disease we are getting 509, and for zero, that is no heart disease, we are getting the value as 411. Okay. So we have discussed everything related to it, like how we need to handle like how we need to do the basic part of it, like how we need to take the duplicates, how we need to calculate the duplicates, missing value, everything, and how we need to do the data wrangling, how we need to do feature engineering, everything on the data set that we have discussed. So after this, we'll just save this file using the like this pre-process file we will be saving that, and then we will be going down in another file to see how we can visualize it. For the further ED analysis, we will be going down to another collab file. So for today, we won't be continuing up here. So in the next session, we'll start it from here and we'll see how we can visualize this data accordingly and can get some of this interactive and colorful chart visualization to understand what exactly my data set is showing us and what we are understanding from the data. Okay. So guys, hopefully you have understood everything in today's session. If there is anything missing, you can definitely let me know. We can understand that, like we can keep a session to understand all of it accordingly, and we can just take that accordingly. Okay. So thank you guys for joining today's session. We'll just connect in the next session accordingly, and we'll continue with the visualization part. Okay. So thank you everyone. Bye. Good night.